Hello, hello, hello. Welcome, Mr. Future Me. I know you are only watching this video or live stream. Let's just say it's a video. Mm, it's 4th January 2026, and we are at day 20. Mm, Today we'll be looking at maneuver test and other things. What are those? Let me see. Maneuver test based in statistics and feature selection matrices. Oh yes, I had to say something about yesterday's network traffic was too bad, so the video was cutting in half. Like three video came out, and in one I made one private. It was around 15-20 minutes, so it didn't matter, but um, that was it. And let's hope it will not be like that today. We'll try to finish this like revision, so we'll be finishing that maneuver test and easily. Okay. And we'll be looking at exploratory data analysis today. Also, there is a bug in this uh, article sections. There are 5 articles shown here, but it's saying it's 6, and the progress is at 94%, which is not right. And other things, others are, we are 20% complete in the whole course, so that doesn't really matter. And okay, we'll start off by doing typing. And I was trying to make my hair, is it standing up? But okay, let's go to the screen, right? uh, Let me make some changes here and there. Okay, everything's good. A to Z. We'll start. We'll start and be there for. Okay, we're back, right? Recently, I have not been able to complete deep learning course because I have to do other stuff, and I'm learning only this right now. I'm only learning this much, like for 2 hours only. I'm studying, and I'm studying extra for my university course, like cryptography and DAA, like that. There are courses. So this one is of Google's machine learning course, and this one is of 100 days of machine learning. Okay, so far so good. Let's start.
इसीलिए मेडल नहीं आते दोस्तों.
Oh, that was about, I was watching this video, and
Got a one-track mind and it can't go right, cause it knows you're dying to leave. So I go and say 2 lies when I won't go high till I'm fine, didn't make it to 3. Wasting every miracle, treat it like it's set in stone. Saw it in reverse and
I have to get it up to 10. Yeah.
I don't trust us to turn this shit around. I always say things upside down. I don't trust us to turn.
If I concentrate, then definitely.
Always say things.
I'm back. I forgot to set the timer. Let's do this for 10 minutes. No, I'll do this for 5 minutes. Okay, 5 minutes will be enough. Highlight.
Is it lying when I tell you that I'm wrong? But I've been feeling all this hurt and so much damn pain. I was trying, couldn't give you what you want. Isolated, everyone is such a damn shame. Take me out, take me out, take me out, take me where I need to go. Way up in the clouds, I know you're so. Keep me when I'm down, I know you'll let me wash away. Leave it all to fate. Stuck in yesterday, and I can't go back. Take me where the angels are and let me die in peace. Take me someplace very far where I don't have to
6. 10, 6. I clicked the. So many mistakes. Or don't confuse that. Good.
She's leaving with it, said she can keep it. I'm a firm believer, no leaving. I better feed the meter. Every time I see her, my knees are weaker. Ain't breathing either. Nothing sweeter, that burning fever, my heat. How can I be homophobic? My bitch is gay. Hitman in a top try, see a man topless, even a stick is gay. Hugging my brothers and say that I love them, but I don't swing that way. The man them celebrate Eid, the trap still running on Christmas Day. Somebody told Doja Cat that I'm trying to indulge in that. In my great tracks, you see the bulge in that. See the motion clap when you're throwing it back. These females planning on doing me wrong, so I'm grabbing a dome at the Trojan pack. Post the location after we're done, can't slip and let them know where we're at. I don't know about you, but I value my life. Cause imagine I die, and I ain't made 100 M's yet. There's so much things I ain't done yet, like fucking a flight attendant. I don't party, but I heard Cardi there, so fuck it, I might attend it. Gotta kick back sometimes and wonder how life would have been if I never did take them risks and would have I prospered. Floating and I won't go under. Been out of town for a month. Absence made the love grow fonder. UK rap or UK drill, gotta mention my name if you talk about the genre. Alright. How can I be homophobic? My bitch is gay. Hitman in a top try, see a man topless, even a stick is gay. Hugging my brothers and say that I love them, but I don't swing that way. The man them celebrate Eid, the trap still running on Christmas Day. How can I be homophobic? My bitch is gay. Hitman in a top try, see a man topless, even a stick is gay. Hugging my brothers and say that I love them, but
It's not even stopping gas. Fuck off. Shit. That was good, right? Sorry. S and A. Why am I always confusing about S and A? Look, I'm always clicking it. Okay? South. Why am I writing South? It's Suit.
If this world was mine, I'd take it, dreams and make them multiply. If this world was mine, I'd take it, enemies in front of God. Introduce them to that life, hit them strictly with that fire. Fire, 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 fire. Hey, Roman numeral 7, babe, drop it like it's hot. If this world was mine, I'd take it, dreams and make them multiply. If this world was mine, I'd take it, enemies in front of God. Introduce them to that life, hit them strictly with that fire. It's a vibe, he a dance, let them watch. She a fan, he a flop. They just wanna kumbaya.
There is back. South. Otherwise, I linger here or here.
Ain't nobody break up and break even.
This is last again.
Said you wanted
30
real love,
minutes.
that's fleeting. Tryna make up, you just wanna make up reasons. Break up and break even. Said you never change
Oh, if I
us,
get
but
not
you're
this.
leaving.
Damn.
Left with a piece of my heart bleeding. Tryna make up, you just wanna make up reasons. Yeah. It's never mutual. Somebody's gotta lose it all, it's the usual. Two bodies gotta give it all to make it beautiful. One body to the day before, it's delusion. Fewer calls every other week, are we losing it? All my words, we don't even speak while you using me. You were gone, like nothing for me, it's confusing me. All the name brand clothes that you wore, how did you afford them? Gave you what I own. You still had the same plans for the unknown. You always wanna call, it would never be alone. Know that I'm the same man that you fell in love with. Remember when you swore we would never go.
Bro, why? Yeah, why?
When you lose all that you know, ain't nobody break up and break even. People wanna trade up, wicked treason. Said you wanted real love, but that's fleeting. Tryna make up, you just wanna make up reason. Break up and break even. Said you never change us, but you're leaving. You left with a piece of my
It's not clicking, yeah.
tryna make up, you just wanna make up reason.
A is being
Ain't nobody break up and
Look,
break even.
shift
People
is
wanna
not
trade
doing
up
it.
but get treason. Ain't nobody break up and break even. Break even.
Huh? No, new keyboard man. What can I say? Let's wait at here. Let's leave it at that. Let's look at multivariate analysis of variance. Okay, Manova. I'm getting dips. Oh, what I wanted to say. Look at that. It shows six articles, right? And it's 94. I assume, right? 1, 2, 3, 4, 5. So it's showing I have not read the articles, but it's only 6. It's only 5. 1, 2, 3, 4, 5. Article 6. I don't know where that invisible article is, but I can't see it. This much I can't see it. If I can't see it, then it doesn't exist. Let me read it out loud to actually make me concentrate, okay? Okay, when to use manova? Manova is appropriate when there are two or more dependent variables that are correlated. There are one or more categorical independent variables. Oh, forgot to show you this quiz, right? I thought it was stupid, decent, and in fast I clicked this and submitted, but it was that, and these were pretty easy. This was this, and derivative of L in respect to n is easy, 1 by x. Chain rule is also easy at its f, and it's gx f. Derivative gx is minus sin x log x, and log x derivative is 1 by x. This one also, the formula is multiplied by xi, and there are no xi, so I clicked it. That is the right. What does Jacobi matrix represent? So I thought it was partial derivatives of vector valued functions, but then I thought vector of first derivative for scalar function, right? So confused in that, clicked other. How is Hessian matrix gradient? It is the gradient of Jacobi. It is the Jacobian of gradient. So in hurry I clicked here, but it was Jacobi of gradient. And in multiple dimension, oh, I was right about it, right? It is multiple choice question and I can choose multiple, right? And I clicked on positive definite, but there was Hessian is negative definite too. So I didn't see this. What is this? This bullet to choose, right? And I only clicked on that and submitted, but my response was incorrect. I clicked here, but I didn't click this one. That's why it's incorrect. And this step size should be smaller. This one is for high curvature, right? So that was what I did when I was recording, right? It was showing recording, but it was caught off in that moment, I guess. Anyway, where were we? Yeah, we were at that. Two or more dependent variables that are correlated. There are one or more categorical independent variables. The data meets the assumption of normality, homogeneity of variance, and independence of observations. The researcher wants to examine the interaction effects between independent variables on multiple dependent variables. That is when to use it, okay? Assumption of maneuver. So, what are the assumptions of maneuver? Before conducting a maneuver test, certain assumptions must be met. Okay? Multivariate normality. The dependent variables should be normally distributed for each group. Homogeneity of variance covariance matrices. The variance covariance matrices of independent variables should be equal across groups. Linearity, the relationships between dependent variables should be linear. Absence of multicollinearity. The dependent variables should not be highly correlated. Sufficient sample size. The sample size should be adequate to ensure reliable statistical results. The manual test for feature selection. In this implementation, 150 samples with 6 independent variables and 4 dependent variables computed with some noise are analyzed using MANPA. The goal is to identify significant relationship between independent and dependent variables, enabling feature selection by retaining key predictors, reducing dimensionality, dimensionality, dimensionality. Retaining key predictors, reducing dimensionality, and enhancing modal efficiency. Before its implementation, we should have some basic knowledge about NumPy, pandas, and stats model. Reducing dimensionality, and enhancing modal efficiency. Dimensionality. Import pandas as PD, pandas for organizing as table, and numpy for calculation as mp, satsmodel.api as sm, and satsmodel multivariate manova, import manova. Okay, so np.random.seed42 gives sets the random seed for reproducibility. So if I want to do this test with the samples, and I want the answer to be exact, then I'll give the seed of 42. A number of samples 150, independent features pd.data frame, so it's for data frame, that's table, we can see it as a table. Feature 1, this is a dictionary. Okay, and feature 1 is a random normal 10 to norm samples. Okay, that is 150. Dependent variable y.pd.data frame, yeah, concatenate x and y. From formula, and what of from formula, all the dependent variable are target 1, target 2, and target 3. Oh, oh, I can run this, but it will not compile. I know. No need to give me hope. I know about it. I haven't texted it. Let's do the test in our own here. Okay, we'll do the test, but I have to do the test for this one also. I forgot about that yesterday. Mm, not the partial derivative. Yeah, this one. This one. Others we don't have to. Chain rule one, right? Okay, let's try to do those. And we'll try to do this also. This one was. Mm, Okay, features with p-value less than 0.05. Select the significant predictors. Yeah, got it. Multivariate linear model. Pillars trace weekly lambda to determine significance. Returning trace row is largest root. Okay, the load p-value defines that there are significant differences. Types of maneuver: one-way maneuver, two-way, and repeated measure maneuver. Compares means of multiple outcomes variables across three or more groups based on one independent variable. Example: effect of different drug treatments on weight cholesterol. Two-way maneuver compares mean across multiple variables using two independent variables. Example: effect on drug treatment and blood group on weight and cholesterol. Repeated measures maneuver used when same individuals are measured multiple times, accounting for represented data points, explanatory variables, independent predictors, draw pill ABC, outcome variables, dependent response, weight, cholesterol, treatment ABC, weight, cholesterol. The diagram highlights how explanatory variables connect with multiple dependent variables in each method. MANOVA versus ANOVA. Here is difference between ANOVA and MANOVA. Feature: ANOVA variable 1, 2 or more. Mean difference in a single variable, combining difference across multiple variables. Test score only, test score plus satisfaction rating. Applications of Manova in machine learning. Feature selection. Manova helps in identifying the most significant features for classification models. Mm, medical research used to analyze the effect of treatments on multiple health-related outcomes. Marketing analysis helps in studying customer preferences across multiple products or attributes. Behavioral science used to analyze the responses on psychological tests across different demographic groups. Bayesian statistics and probability. Hmm. Okay. Okay. Bayesian statistics sees unknown values as things that can change and update what we believe about them whenever we get new information. It uses Bayes' theorem to combine what we already know with new data to get better estimates. In simple words, it means changing one initial guess based on the evidence we find. This ongoing update helps us deal with uncertainty and make smarter decisions as more information comes in. For example, when flipping a coin, usually statistics say there's a 50% chance of head. But if you already know the coin might be heavier on one side, Bayesian statistics let you use that knowledge to adjust the chance of heads. Before understanding Bayes' theorem, let us first understand conditional probability. Conditional probability is the probability of an event occurring given that the event has already occurred. It is denoted by P. When B is given, the probability of given event A given event B, the probability of event A given event B, probability of parameter theta given observed data x, Joy probability of theta and x, probability of observed data x marginal. Bayes theorem. Bayes theorem is a mathematical formula that describes how to update the probability of a hypothesis based on new evidence. In simple terms, it allows us to calculate the posterior probability updated belief by combining the prior probability, prior belief, and the likelihood of observing the evidence. Mathematically, Bayes' theorem is expressed as uh, probability of theta when given x is probability of x given theta dot probability likelihood and evidence. Okay, so marginal likelihood, prior probability is posterior probability, updated belief after observing the data. Xi is likelihood, the probability of observing the data given the hypothesis. Disconnected again. Disconnected again. Okay, reconnected. What is happening with this OBS studio, man? If this was cut off, then I'll I'm always sleepy when there's direct light. Okay, maybe this one. Partial blocked. I know about that. Because I'm using the song, right? Uh, the visibility is bad. No problem. Don't care about that. Don't care about that. So even if it's partially blocked, I don't care about that, or I don't care about my live stream. Hmm. Don't care about that. Don't care about that. So even if it's partially blocked, I don't care about that, or I don't care about my live stream. Oh, why am I looking like that? Damn. Don't care about that. Let me see what I can do. There, okay. We'll do the test, but I have to do the test. Yeah. I'm so far away in the screen. Got it. Got it. It's slanted, that's why. Yeah, it's slanted, that's why. Pillars, trace, clicks, lambda to determine significance, certain trace, row is largest root. I guess I have to talk like this too. Variables, example, effect on draw, treatment, time curve, to operate, and cholesterol. Come variables, dependent response, weight, cholesterol level, on treatment. It's a plus multiple variable. This score only, this score plus exception rating. Behavioral science used to analyze the responses on psychological tests across different demographic groups. Bayesian statistics and probability. Okay, good. This is good enough. Okay, fine, right? Let's start again. I'll do the. Yeah, this is good enough. Okay. Um, where was I? Yeah, I was in Bayesian statistics component. Probably. What probably? Bayesian probably. Okay. I will be talking like this. There's no need for my earphone because there's no output capture, right? So I don't need to wear that earphone. And let's be a little more energetic, even if it's sleepy. Let's be energetic and do our work. So, Bayesian statistics components, right? Bayesian statistics uses three key parts: the likelihood function, prior belief, and posterior belief. These help handle yes no outcomes and let us update our beliefs as we get new information. Let us understand them one by one. So, likelihood function, the Bernoulli likelihood function. Likelihood is the opposite of posterior probability. Likelihood function The Bernoulli likelihood function is used for binary outcomes like success or failure. Like if we are studying the probability of a customer clicking on an ad success or not clicking failure, this function helps us identify how likely it is to observe specific data given the probability of success. So, mathematically, the Bernoulli likelihood function is represented as probability of x given theta when theta power x product of 1 minus theta power 1 minus x. Here, x represents the observed data, 0 for failure, 1 for success, and theta is the probability of success, click rate, and x is the observed outcome, 0 for failure, 1 for uh, success. Prior distribution. Before we observe any data, we have some prior beliefs about the parameters that we are estimating. For example, we might have an initial belief that the probability of a customer clicking on an ad is around 0.3. The prior belief distribution reflects this knowledge. A commonly used probability parameter is the beta distribution, which is used as the prior distribution for parameters like theta. Okay, the prior belief distribution is mathematically expressed as uh, theta power alpha minus 1 dot 1 minus theta power beta minus 1 divided by beta alpha and beta divided by b alpha and beta. So sleepy. Where theta represents the probability of success, alpha and beta are parameters that control the shape of beta distribution. B alpha comma b beta is the function which ensures the distribution integrates to 1. Posterior distribution. Once new data is available, we use a Bayesian theorem to update our beliefs. The updated belief is represented by the posterior belief distribution, which combines the prior belief and the new evidence. P theta probability of theta when given x and probability of x when given theta into probability of theta. Okay, once new data is available, we use Bayes' theorem to update our beliefs. The updated belief is represented by the posterior belief distribution, which combines the prior belief and the new evidence. The posterior distribution shows the updated probability of success or failure after we observe the data. As we receive new data, our beliefs about parameter will change accordingly. So this graph explains how Bayesian statistics update our understanding of relative risk by combining prior beliefs with new data. The green curve represents the data which suggests the possible values of for the risk based on observations. The red curve is the prior which show our belief about the risk before seeing the data. The blue curve is the posterior, which is updated belief after combining both. A steeper posterior means the data has a strong influence, while a flatter posterior means the prior has more effect. So the green curve here is the data likelihood, and red curve here is the prior, which shows our belief about the risk before seeing the data, and blue curve is the posterior, which is updated belief after combining both. Okay, and steppier posterior means that data has a strong influence, while flatter posterior means prior has more effect. Okay, why did the value chains again. It's always being like this. Where's my obvious like this? This is bug. Not really, right? Examples of Bayesian statistics and probability. Suppose a patient takes a test for a disease that affects 5% of the population. Prior probability 0.05. The test results depend on sensitivity, 95% chance of a positive result if the patient has the disease, negative false negative rate, 5% chance of a negative result despite having the really disease, false positive rate, 10% chance of a positive result without the disease, and specificity, 90% chance of a negative result if the patient is healthy. The patient tests positive. Using Bayes theorem, we update our belief about the patient having the disease. Disease when positive, positive when disease, into probability of disease and probability of positive, where probability of positive is equals to uh, probability of positive given disease and probability of disease, the probability of positive when no disease, and product probability of no disease. This calculation helps estimate the true chance the patient has the disease after positive test. Why not frequentistic approach? The confusion between frequent, frequent, frequentist, frequentist and Bayesian approaches has been constant for beginners. It's important to find the difference between these methods. Frequentistic, frequest, frequent, frequentist statistics relies solely on observed data and long-term frequencies, often ignoring prior knowledge. It uses point estimates and hypothesis testing with p-value, which can lead to rigid decisions. Bayesian statistics incorporates prior beliefs and updates them as data accumulates, offering more nuanced probability statements. This is especially useful for unique events or when data is limited. Practical use cases of Bayesian statistics and probability. Spam filtering. Bayesian filters learn from email characteristics to classify messages as spam or not. Marketing and recommendation. Personalized suggestions are made by continuously updating user preference models. Probabilistic modeling Bayesian methods capture uncertainty in data and model parameters useful in finance and customer behavior analysis. Bayesian linear regression, unlike classical regression, it estimates distributions over coefficients, helpful with small or noisy datasets. A/B testing provides full probability distributions over outcomes, offering richer insights in than simple p-value. Introduction to metrics. I'm finally there. My matrices. I love you. Linear algebra. Oh oh. Oh oh. They look so good. Man, wow. Uh, Feature selection using chi-square test. Didn't we do this? Okay, we have to do this. Customer versus behavior dot. You can download the dataset from here. Where? Oh, here. Oh, sorry. It was here. Customer purchase.csv. Oh, we'll be looking at that. Let's go. We'll be doing this. Data cleaning. Okay, okay. Okay. Loading iris dataset from Skylar. Fanova. Feature ASCII. Feature selection. Okay, okay. Now we have to do practicals. Okay. These are the times. First we'll read this, then matrices, then we'll do this, these, and there's one maneuver too. Yeah, there's one maneuver, there's one in chain. Okay, I'm not forgetting. Ah, I'm so sleepy. I thought I had to go out and sleep right now, and hmm, we are 1 hour 17, so we are 1 hour late. What can I do? How many quizzes are there? There are 15. To compare means of a single dependent variable across groups, to compare multiple dependent variables simultaneously across groups, to analyze the correlation between two variables, to test for outliers in dataset. Yeah, therefore not an assumption of multivariate normality, homogeneity of variance, covariance, matrices, sufficient sample size, dependence of the dependent variables. Significance, weeks lambda. It was done there. Don't think other are there. Okay, we'll do this after. I'll look at it and I'll do. If there's wrong, then there's wrong. Nothing I can do about it. How much? 95. Okay, introduction. No. Use of maneuver test based in statistics and metrics. In data science, we often deal with problems involving multiple variables or uncertain outcomes. Maneuver Bayesian statistics and matrices are advanced statistical techniques used when traditional methods like a single t-test or basic probability are not enough. They provide better insights, especially in multivariate analysis or when incorporating prior knowledge into predictions. MANOVA test in data science. MANOVA multivariate analysis of variance is used to test where differences across multiple outcomes at once, avoids increasing error rate due to running multiple ANOVAs, detects interaction between variables. And example, user engagement across regions. Suppose you are testing if users from three regions differ in time spent on site, number of pages visited. Instead of running two separate ANOVA tests, you use MANOVA to test if both metrics differs together by reason. If the result is significant, it means at least one group behaves differently across at least one metric. Use cases: evaluating effect of marketing campaigns on multiple KPIs, testing user behavior differences across segments, comparing model outputs across several performance measures. Bayesian statistics in data science. Bayesian statistics updates priority estimates as new data becomes available. It helps to incorporate domain knowledge or previous results. Okay. Works well with small data sets, provides priority based outputs instead of binary conclusions. Example: spam detection. Suppose you already believe 20% of emails are spam, prior belief, then based on the words in a new email, you calculate the likelihood it's spam. Based in methods combine both pieces to give a posterior probability exam. 90% chance. Use cases: recommendation systems with prior user behavior, fraud detection with evolving patterns, updating model predictions as new data arise. Matrices are foundational in data science for representing and manipulating structured data. They help in organize multivariate data for analysis, support fast computations using libraries like NumPy, PyTorch, etc. Power. Oh, 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 oh. Man. Okay. Power core operations in machine learning, linear algebra, and statistics. Suppose you have a data set where each row represents a customer and each column a feature like age, income, purchase frequency, etc. This data set is naturally stored as a matrix form, and we can perform matrix operation on it for further analysis. Use cases: storing datasets in tabular 2D form, performing matrix multiplication in linear regression and neural networks, representing and transforming image data in computer vision, calculating eigenvalues slash vectors for PC and dimensionality reduction, encoding text data in NLP using word embeddings as matrices or tensors. So It is used for a lot of things, and this is super useful. Let's go and look at it. So matrices are rectangular arrays of numbers, symbols, or characters where all of these elements are arranged in each row and column. A matrix is identified by its order, which is given in the form of rows and columns, and the location of each element is given by the rows and columns it belongs to. So it's 1, 2, 3 m, and 1, 2, 3 n, m into n rows. Okay, dimensionality. Dimensions. Our matrix is represented as P, M, and X, where P is the matrix, M is the number of rows, N is the number of columns. Given below is a general example of a matrix. Yep, this is a general example of matrix. It is of the matrix is I is A. I means rows, first row, second, third, mth row, and column, first row, second, third, and row. In mathematics, matrices are mainly used to represent and solve systems of linear equations, perform linear transformations, and study concepts like eigenvalues, determinants, and vector spaces. Eigenvalues, determinants, and vector spaces. Mm, these are important. These are also these are necessary. These are important. I should look into it, but I have so much to do already. So, not really. Some common examples of matrices are 1, 2, 3, 4, 2 into 2, B is equals to 1 minus 1, that is 3 into 3. A is a 2 into 2 matrix and 3 into 3. Order of matrix. The order of matrix tells about the number of rows and columns present in a matrix. The order of matrix is represented as the number of rows times the number of columns. Then let's say if a matrix has 4 rows, 5 columns, then the order of matrix is 4 into 5. Always remember that the first number is order signifies the number of rows present in the matrix, and second number signifies the number of columns in the matrix. Operation on matrices. We can perform various mathematical operations on matrices such as addition, subtraction, multiplication, and scalar multiplication and multiplication. These operations are performed between the elements of two matrices to give an equivalent matrix that contains the element that are obtained as a result of the operation between the elements of two matrices. Addition of matrices. In addition, matrix addition or subtraction of matrices, the operation is performed between two matrices at the same order to yield a matrix that contains elements obtained by performing the operations on the elements of the two matrices. The addition of matrices A and B. This is that. Simple. It will be this. It will be 3, 5, 10, 12. 3, 5, 10, 12. Subtraction of matrices. The such two matrices can be represented in terms of addition of two matrices. Let's say we have to subtract matrix B from matrix A. Then we can write A minus B. We can also write A plus minus B. Okay. Subtraction of matrix is same as that. 2, 3, 6, 7, 1, 2. Okay. Subtract this from this. So subtracting this means it will go front from there. 2 minus 1 1, 3 minus 2 1, 6 minus 4 2, 7 2, 1 1 2 2. Yes. Scalar multiplication of matrices. Scalar multiplication and reverse multiplication each term of matrix by a scalar that is a constant. If a scalar gets k multiply matrix product 3 multiply everyone. Multiplication of matrix. These, these plus these. Okay, and again for yes. Okay, guys, I have to go in half an hour, so I have to complete these all faster as more. Okay, faster as possible. In multiplication, we multiply a into this plus a into this again for this value, right? For this value, b into a, then again b into a, again for this. These two will be multiplied, added for down this value. These two will be multiplied again like this. This, this. It's going like this. This. Okay, it's multiplying like this. You can visualize, right? It's easy, and I'm not gonna read that. It's too much of a hassle. Transpose, yeah, transpose of a matrix is rearrangement of two row elements in columns and column elements in rows to yield a equivalent matrix. A matrix in which the element of row of the original matrix are arranged in columns or vice versa is called transpose matrix. The transpose matrix represented as AT if A is a MNX where B is AI and A is AI. Okay, I'll give you a trick, that is keep A as it is and F it is as it is, then rotate this. So A B C A B C and D E F D E F. So that it's just, this is the matrix, right? This is the matrix. Then it's like this. So this is the matrix like this. This 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 is the point, right? And this is the back 1 and 7, and it's just like that. You can imagine it's just row with column and column with row, nothing so serious. Look at this, it's like this, right? Square, so it's, so square, this only change. Trace. What's trace? Trace of a matrix is the sum of principal diagonal elements of a square matrix. The trace of a matrix is only found in case of square matrix because diagonal elements exist only in square matrices. This, say an example. Okay, trace is summation of diagonal. Types of matrices based on the number of rows and columns present and special characteristics shown. Types of matrices are classified into various types. Row, column, horizontal matrix. A matrix is the number of rows is less than vertical, rectangular, square, diagonal, zero or null. Matrix whose elements are all zeros. Unit where all are one. Symmetric. If the transpose of the original matrix is equal to its original, okay. Skew symmetric matrix, where the skew matrix is a square matrix whose transpose equals to its negative, and connected again. Yeah, it's reconnected again. It's no data, right?